Hey everyone, so today we are going to talk about problem solving strategy. So what we are going to do is we are going to apply the strategies in problem solving, especially the model designed by POLYA'S, no? The four-step process. Okay, so let's discuss first the POLYA'S four-step process. So this is the most common problem solving steps that we usually do in solving mathematical routine and non-routine problems. So, okay. So, the four steps follows the following: understanding the problem, devising a plan, carrying out the plan, and looking back. Okay, understanding the problem. So, here are some guide questions we need to ask in understanding the problem. So, what sort of problem is it? Okay, so is it a algebraic, geometric, or is it like a puzzle? What is being asked? So that is very important. No? So we need to address what is being asked in the problem. So what are the terms? So if there are unfamiliar terms, so we need to unlock them, or symbols or notations. Is there enough information or more information? So we need to determine if is enough information in order for us to solve the given problem. What is a known and what are unknown? So here are the things you need to do in understanding the problem. So learn the necessary underlying mathematical concepts. Okay, consider the terminology and notation used in the problem. So you have to unlock all of those. Rephrase the problem in your own words. Okay, so try to translate it in your own words. Okay, uh, as they have said, no, if you can translate the problem or anything in your own words, meaning that kind of concept, you really have understood that type of concept or what is being stated. So write down specific examples of conditions given. So you have to list down all the conditions written in the problem. Next one is devising a plan. So what are the questions you need to ask in devising a plan? So how are you going to attack the problem? So when you say attack is, how will you start? How will you start? So what would be your first step in solving the given problem? Okay, have you encountered a similar problem before? Can you use that one in order to solve the given problem? So you may refer to other mathematical problems you have solved. Maybe you try to compare it, or you may found it in a book. So you may try to look onto it and try to apply if that kind of solution would work in this new problem that you are working with. Okay, so here are the tasks. So just simply decide for a possible strategy. So here are some possible strategies. You have draw pictures, use variables equations, solve simple problem, be systematic, or you may apply guess and check, or the trial and error, or you may look onto patterns, or making a list, or organize the data. So in the next video, I will show to you how would each of these strategies would work. Okay, next one is carrying out the plan. So carrying out the plan. So this is here you are going to solve now your problem, no? Or you are going to show your solutions. So what are the things we need to ask in carrying out the plan? So can you see clearly the step is correct? So are you doing it right? Can you prove it that it is correct? Okay. So you have to see to it that you are doing it correctly, especially on the steps, the processes that you are going to undertake while solving the problem. So what are the things you need to do in carrying out the plan? So you have to try each plan that would lead to a solution. No? So if plan A won't work, yeah, to do plan B. If plan B won't work, then proceed to plan C and so on. Okay, so just keep trying until something might work. No? So keep trying until you will get the solution. Now let's go proceed with looking back. So what are the guide questions in looking back? So did you answer the question? So this is the most important thing, no? So did you really answer what is being asked? Okay. Next is your result reasonable? So what can we say if result reasonable? Can you check your answer? Can you prove it right or wrong? So that is the thing. Can you check or verify your answer? That is the thing you need to answer here. Is there another way you can solve the given problem in a simple way? So it might be halfway. You have discovered a simple way, a simple manner of solving the given problem. So you may show it here in this part. Can you use the result or method for some other problem? So based on the solutions that you have, can you apply this, or would this type of solution would work onto another problem? So what are the tasks? So check or verify if the solution really works. Next is try to discover if other method would be applicable to solve the given problem, or try to make a generalization about the problem. Okay, next is try solution that can be applicable to the other problem. Okay, let's have some example now. Let's try to solve this given problem here. Let us say every person of the party of 28 people would say hello to each other. So at exactly once. So we are asked how many hellos were said in the party. So in understanding the problem, so let's try to review all of those steps. Okay, what is being asked here? So we are asked to determine the number of hellos that is being said. So what are the conditions we need to satisfy? So there are 28 people, and each one would say hello to one another once. Okay, can you draw an illustration to better understand this problem? Okay, so I will just leave this part to you. Okay, you may have different illustration to this given problem. Next part, devising a plan. So based on what you have understood the problem, what possible strategy can you apply? In my case, I would apply patterns. No? So you may use any other strategies depending on which strategy you are comfortable using with. No? So you may use one, or you may use a combination of 2 or 3, or as many as possible strategies as you can, as long as they will work. No? So what operation or mathematical concept will be involved? So I guess I would use multiplication or sequence. You can name as many as you can. No? Okay, how will you start your solution? Okay, so we may have different way of solving it. So I will just leave this part to you. No? Okay, so carrying out the plan, this is my solution. I did use the patterns. So my answer here is 756 hellos. Okay. So I did use the pattern 1 times 2, 2 times 3, 3 times 4, 4 times 5, and 5 times 6, and n minus 1 times n, and so on. Okay, so let's go to looking back. Okay, can you verify if the answer is correct? Okay, by reviewing the pattern, it follows the formula a sub n equals n minus 1 times n. No? So can you do it in another way? So another way of solving this one is we apply the principles of counting. Since each one of them will say hello 27 times and there are 28 of them, then I will say they will be 27 times 28, which is equal to 756 hellos. How can you extend the problem? So I could extend it with this one. So if there are 28 people will handshake to one another once, how many handshakes would there it be? And my solution would be 27 times 28 divided by 2. Since divide 2, since for 2 people, they would only handshake. There is only one handshake, no, for every 2 people. And I guess that's